I'm going to do a video presentation of my project. My name is Priyanka Debarma. My registration number is 16513100018. Doing project under the guidance of Mr. D. Kathirvello, Assistant Professor of Biomedical Department, SRM University, Katankulatu. My project title is Lung Tumor Delineation and Classification of Different Stages of Tumor by using PET-CT images. The aim of my project is to study about the lung tumor delineation approach that is based on ground truth method in PET and CT and classification different stages of the tumor. The objectives of my proposed method are pre-processing of the CT image, multiplying the pixels dimensionality, after that segmentation and GLCM using for feature extraction. Under GLCM I am doing texture analysis. After texture analysis I am classifying the different stages of tumor by neural network pattern recognition tool. And the next is tumors of the lung. There are two types of tumors of the lung. First type is primary or benign and second is secondary and malignant. In primary lung cancer, the overall cure rate is very low and the disease has a 90% death rate. The risk factors may be cigarette smoking, occupational hazards like nickel, chromates, and 80% of lung cancer patients are cigarette smokers. In secondary lung cancer, secondary cancer in the lung is when cancer cells are spread to the lungs from a cancer that began elsewhere in the body. And these two images are the first and second stages of the lung cancer, and these two images are the third and fourth stages of the lung cancer. And the next are the advantages of proposed method. The advantages of my proposed methods are tumor detection can be done exactly, gives more exact output, and it is easy to implement, and in contrast image it gives exact output. This is the block diagram of my proposed method. The first is the input image. After giving input image, I'll do pre-processing. After pre-processing, I'll do the filtering of the image, and then I'll do the segmentation for detection purpose. After segmenting, I'll extract the features. After extracting the features, I'll detect the tumor part, which area are affected, and after detection of the tumor part, I'll do the classification of different stages of the tumor. And this is the methodology of my proposed work. First is the input image. The natural scene image for text detection gives as an input image. In imaging science, image processing is any form of signal processing for which the input is an image. The input of image processing may be either an image or a set of characteristics or parameters related to the image. In pre-processing, I'm removing low frequency background noise, normalizing the intensity of the individual particles, and removing reflections, and analyzing the size of the input image resides in, and checking the pixel values. And then at last I'm doing masking, where I'm removing the unwanted portions of object which is not relevant to my work, which is called masking. There are two types of maskings. One is pixel dependent and the other is pixel independent. And next is segmentation. Under segmentation, I'm multiplying the image by pixels dimensionality. After multiplying the pixels dimensionality, I am detecting the length and properties of the multiplied image by maximum and minimum length and by the use of region properties. After that, I am checking the centroids of the image. Centroids means major axis length, minor axis length, area, and find the region properties and function. The gray level of pixels belonging to the objects are quite different from the gray level of pixels belonging to the background. So under thresholding, I am giving thresholding value as 180 to 210. And then is feature extraction methods. There are three types of feature extraction methods are texture, color, and edges. In GLCM, I am analyzing the texture features. It is a second order statistics measurement that contains information about the positions of the pixels having similar glare level values. Texture features can be extracted in several methods. These are statistical, structural, model-based, and transform function or information. In texture analysis, it is a well-known algorithm to extract features is the use of gray level co-occurrence matrices, which belongs to the statistical methods. The GLCM contains a second-order statistical information of spatial relationship, the pixels on an image. The GLSM contains information about how often a pixel with gray level value I occurs with horizontally, vertically or diagonally to adjacent pixels with a value j. Features extracted from GLCMs are contrast, correlation, energy, homogeneity and entropy. The first is the contrast. Contrast measures the amount of the local variation in the image. It is the difference between the highest and the lowest values of a contiguous set of pixels. And the correlation measures image linearity. Correlation measures the gray-tone linear dependencies in the image. Energy returns the sum of the squared elements. Energy is a feature that measures the smoothness of the image. Next is homogeneity. Homogeneity returns a value that measures the closeness of the distribution 6 of elements in the GLSM to the GLSM diagonal, and the ranges will be either 0 or 1. Homogeneity always measures that takes high values for low contrast images. Entropy, it is a disorder or uncertainty. It measures the uncertainty of gray level intensity values of the image. The next are the values which I have segmented or extracted the features. These are the contrast, correlation, energy, homogeneity. Contrast is 1.6464, for correlation is 0.9813, and for energy 0.7845, and the homogeneity is 0.9912. These four features are for my input image, which I have shown in this PPT. This is the input image which I am using, and this is the segmented image. The first image is after masking, where I have removed the unwanted portion of my segmented process. After that, this is with the low frequency background noise, and this image is after removing the low frequency background noise. After removing low frequency noise, it will detect the tumor, or which are the affected part. And next is the neural network classification. After detection of the tumor part, I will classify the tumor in which stage a tumor is. Classifying a tumor as benign or malignant, it is based on uniformity of cell size, clump thickness, mitosis, and the correct classification as benign or malignant. I am using NPR tool GUI, graphical user interface, by the use of neural network pattern recognition tool or a command line solution. GUI to automatically generate the command line scripts. Before using these two methods, first step is to define the problem by selecting a dataset. So how to define a problem? To define a problem, a pattern recognition problem, arrange a set of q input vectors as a column in a matrix. Then we have to arrange another set of q target vector. After assigning a problem, neural network classifying the size and features of the tumor, and then we'll train these features and we'll check its value. After checking these values, it will show the different stages of tumor, whether it is affected or not affected. These two are the screenshots of my classification of the different stages of tumor, where it will show whether it is benign or malignant. I have attended second international conference on computing combination and advanced network held on 24th March on Chennai Institute of Technology, and proceeding will be published in the Scopus indexed journal. These are the references of my project work, and thank you for watching.